this one? Oh, hey, I think that one's working. Okay. Hey, look, it's working. I think that one's working. Okay. Hey, look, it's working. That one's working. Okay. Hey, look, it's working. That one's working. Oh, no, it's echoing. Stop. Okay, there we go. I've never done this before. I don't think anybody's even present in the chat, so it doesn't really matter. Oh, that's gonna be a little distracting because there's a long delay. Oh well. All right. Oh, bugger. Oh, that was bad. Oh boy. Let's fix that. Okay. Well, now is everything better now? Oh, I think my camera flipped over. That's not good. There we go. Okay. Is that good? Now let's see if I can get this camera to stop wiggling around without knocking it off. Oh, I just did it again. Gosh darn it. Sorry for anybody that's watching. I keep screwing this up. I'm gonna break this stupid thing. Okay. No, do not fall again. I swear. Jeez. Okay, that's good enough. I'm just gonna leave it like that. Don't want to throw it on the floor again. Okay. Oh, I bet that one person that's watching is probably me. Okay. Oh, let's write a quick... I finally got it working. Yay. Oh, that lag is going to be really weird, but I have to watch it to make sure it's working. Just posting the live stream here. Jetboy/live. Okay, so there's that posted, and let's go back to here. Still only one person watching, which is probably me. But that's fine. I'm just gonna start working on this, and as people join, if they join, I will and I will answer as I see them. Okay. Let's Okay, so that should be working. I'm gonna quickly check. I'm going to mute my computer and see if this is working properly. Working properly. See if this is working properly. Working properly. Yes. Okay. So finally, it's set up. Now, I'm just gonna zoom down a little bit closer. There we go. Try not to knock my camera off again. Let's see. Camera enhance. Autofocus off. Because I want to focus. How do I do the focusing here? So we'll go aggressive autofocus. There we go. That looks so much better. Perfect. Alrighty. Let's just get started. Nobody's watching yet, but whatever. Let's see, how do I want to do this? I think I'll do it from this side. Ooh, I need to fix those leads. Oh well. This is going to be mostly boring. Let's see. Huh. Is the super glue not actually adhering to these? That's interesting. That's weird. I wonder if I can just kind of... do that. See if that works. Probably should have tested to see if the super glue would adhere on these before I started gluing them. Oh well. If they don't, I'll just hope that the soldering holds it all together properly. Now, in case I actually decide to upload this as a real video, I'll try to keep a reasonable stream of inane banter going on, so that it's not super boring. Right now all I'm doing is, I've taken the capacitors for this ionizer that I'm going to build, and I've staggered them next to each other so that I can glue the diodes for the Cockroft-Walton multiplier. It'll be easier to solder them. In a second here, I'll go ahead and grab the... Oh yeah, that looks like it's starting to adhere. So, I just realized people can go rewind, so I'm gonna grab the circuit diagram I threw together here. So basically what I'm doing here is, this is a Cockroft Walton, or Walton-Cockroft, depending on how you want to say it, voltage multiplier, which is actually kind of a misnomer because it's more of a voltage adder, because you get the live electricity coming in from the mains here, and this capacitor charges up to the 120 volts or 240 volts of the mains on the first wave of the sine wave, and then as it comes down, this capacitor starts to charge up, and then when the wave goes back up, this capacitor starts charging up, but being as this capacitor is already referenced to 120 volts, this capacitor then gets referenced to 240 volts. So in this first stage, it's just a voltage doubler. But then as you keep going up, each of these capacitors only pushes the waveform up by 120 volts. So it's just adding rather than multiplying. Each stage adds another 120 volts. And it's not ideal because you get the voltage drop across the diodes, and I'll be doing a proper video soon where I go into more detail about how the Cockroft-Walton voltage multiplier works. But for now, we're just actually physically building the thing, because I want to get most of the hard work done ahead of time before I do the real video. So I figured I'd live stream it just for fun, to see if I could even manage to do it. So what I did was I started by laying out a piece of packing tape on the table, and then I took these capacitors, which are X2 mains suppression capacitors at 220 nano farads, which is a fairly beefy capacitor for this, but I want to give the 120 volts mains here in Canada all of the chance it can get to actually add up to a proper voltage for ionization. You can tell I haven't actually really thought through what I want to talk about here, because I hadn't really planned on talking much. So yeah, I just taped these on. The standard ionizer that you'll find in the UK has about 11 stages. This one has 15, this one has 15 stages. This one actually has 30 stages. So it's bigger than your standard one that you'd find in the UK. At least I think that's how it works. Anyway, so I've got the capacitor set up kind of staggered here, because the way I'm going to be soldering the diodes on is I'll be taking them and soldering them on like so that they're going to be laid out diagonally between the capacitors, just like you saw on the circuit diagram that I just drew or showed there. I haven't really planned through any particular script, so I'll try to talk as best I can as I'm doing this. But the next step, what I did was I just ran some super glue down between the capacitors to hold them together, and it seems to be mostly working. At least it's gonna... no, it's really not working, isn't it? I'm hoping that it will adhere them at least well enough to hold it together while I'm soldering them. I guess I'm going to need my wire clippers. Where did they go? Wire clippers, where did you go? This is my standard state of disorganization. I normally plan a lot better before I start working on a video, but like I said, this is just a spontaneous live stream. Alright, well, let's get this show on the road. There's not much I can really talk about while I'm doing this. I guess I'll talk about a little bit about how I'm going to be building it. So this is going to be the mains end. And with the mains end, you have one capacitor by itself, and then the diodes start here with the live going on this pin and the neutral going on this pin. And then that'll be the emitter end on the anode side of the LEDs, which generates negative ions at the tip of the ionizer. This ionizer is mainly just going to be a proof of concept. I've tried to build 2 ionizers previously. The first one kind of worked, but was somewhat unreliable, and in retrospect I think I had it hooked up backwards so that it was generating positive ions at the emitter and was charging everything near it with static. So that wasn't a great result. And the other one I built, I think I had bad components maybe, and it didn't seem to work very well. So this time I've actually gone and measured all of these caps to match them fairly nicely. They're all within 220 to 230 nanofarads, which is close enough. The bag of caps I got was measuring anywhere from 200 to 230. So I tried to match them fairly closely, and I tested all the diodes to make sure that they were good. So rather than just jumping in and assuming that my components are good, I'm actually proceeding with known good components. Not no good components, but known good components. Alright, so I'm just going to start by soldering this diode on here. Still only have one person watching, so it's just me monitoring the stream. So I'll flow the solder onto that one. And, oh, that's what that smell was. I pressed my soldering iron against the frame that I use for my lights here. Anyway, so we'll trim that off. Alright, so the next step is I'm going to just bend these capacitor leads down like so to kind of lock those leads for the leads of the diodes down, and then I will solder it. Oh, I have 2 people watching now. Excellent. Hello, second person, whoever you might be. There we go. And then I'll just crop the rest of these. There we go. Yeah, clipping those off. Oh, I lost the second person. I'm not expecting very many people to show up to this. I only have 400 something odd subscribers. I think I'm at 411 as of this morning. Had a rather sudden jump in subscribers after uploading a review video to Banggood. It seems to be fairly standard. I'll get a sudden influx of subscribers, which I don't mind. In fact, that's a good thing for me. All right, that's good. And we'll just crop these off. I'm gonna have to make sure I pay very close attention to the oh, jeez, where did that go? That's way over there. Hopefully one of the cats doesn't decide that looks tasty. Anyway, I'm gonna have to pay attention, make sure I'm bending these properly. In fact, I need to reflow this and push it in a little bit. There we go. Perfect. Okay. Alright, so we're gonna go ahead and fold this down like so. Yeah, I have to make sure that all of the diodes, the cathodes, are pointing that way. Otherwise, it will also make the whole thing not work properly. All right. We'll just solder these. Oh, wow, that was really warm. Of course it was, you dummy. You just finished soldering it. All right. So I have to be careful not to get overzealous with my cropping of leads and accidentally trim off one of the diodes. That would kind of be disappointing. So I'll put another two in. Those leads are kind of going all cocky bumpus. There we go. I'm liking these ones better than the first couple ionizers I built. The capacitors I used for them had really short leads. And it was really hard on my fingers to bend the leads down, but this seems to be doing quite well. Alright, there we go. Oh, another person has joined the stream. Hello, other person that has joined the stream. Doesn't tell me who has joined, just all of a sudden I've got 2 people watching. Which means me and one other person. So, hello, other person. There we go. Oh, and that person left. I better make sure I'm in frame here. That's kind of an important thing, isn't it? I'm gonna shift the camera down the way a little bit. There we go. Alright, put another couple of LEDs. Well, these are not LEDs. Although that begs the question, I wonder if you could... Well, no, because they're really not meant for operation at 120 volts, but... That would be interesting. Build a small Cockroft Walton multiplier with LEDs for the transmission diodes. I wonder if that would even work. At lower voltages it would. I'm going to go ahead and do a bunch of these all at once. I can really only bend them down 2 at a time to the length of the leads. Oh well. There we go. And oh, that was messy. Try to clean that up a little bit. Yep, that's good. All right. Actually occurs to me that in previous attempts I was probably getting a little bit of rogue ionization off of all these sharp-tipped leads that I'm cropping off. So I'll have to come up with a way to discourage that. Maybe I'll just encase the whole thing in beeswax. Note to self, find a source of beeswax near. I mean, I guess I could also hot glue them, but beeswax is easy because it has a reasonably low melting temperature. It is an insulator, and it is a lot easier to remove than hot glue. I suppose I could also, like, back and oh, that doesn't work very well. I'll figure out something to do about all the sharp tips later. This thing is largely just a proof of concept to see if I can finally get one working without needing a step-up transformer. Right, and we'll trim this. This is, yes, going to be terribly, terribly boring for the building. All right, let me fold these down. Oh, I need to add another other diode before I do that. There we go. So it doesn't seem like I can really get away with doing more than 2 of these at a time, unfortunately. Oh well. This lead folding thing I've got going is working pretty good for me. Nice joint on that one. There you go. And there goes another lead pinging off into the distance. Alright, do and do. Come on, get down there. There we go. Alright. The soldering iron I'm using is actually, I was actually very surprised at how decent it is, given how much it cost. I found it on Banggood. It's a PX978. I was a little bit annoyed because the day after I purchased it, I found out that for just a couple of dollars more, I could have gotten the PX988, which actually has complete temperature control. This one has stages that you can select, just pre-programmed amounts, but the PX988 actually you can control it to the degree. So I was a little disappointed to learn that wasn't actually that much more expensive for the more advanced controls. I may at some point try to pick up one of those just for fun. You can help me accomplish that by clicking on that Streamlabs link in the description, video description there. It will send you to a donation page where you can send me a single donation. Not too sure where the cards, but I should have a card showing for my Patreon as well. Not too sure where that shows. Oh, there it is. Yeah, okay, so if you click that I button in the upper right hand corner, it'll send you to my Patreon page. The Patreon page is a monthly sort of subscription donation thing. And the Streamlabs link is a one-time donation sort of thing. Let's see if it'll even allow me to make a card with the Streamlabs. Oh, it does work. Oh, give me a second here while I set that up. That helps. Let's see. Help support my channel. I'll go with that one. Call to action. One-time donations here. Help fund. Oh, maybe I should put help fund burn cream because I just touched my soldering iron with my elbow. Help fund more projects. There we go. I don't really have any. Let's see, do I have any good? Go with that one. Great card. Hey, brilliant. Okay. Alrighty, so I just added another card there where you can make a one-time donation to help support my channel over at Streamlabs, which is the rendering software that I'm using for the streaming. Gotta scoot this diode down a little bit. There we go. crop these leads off. Have to be careful with my soldering iron here. I don't have a stand for it yet, so it just kind of sits around and singes whatever it gets too close to if I don't pay attention to where it's going. There we go. Alright, I was quickly auditing my diodes here, make sure they're pointing in the right direction, because as handy as this format is for soldering them on, it is a pain in the butt to fix a diode that has been soldered on in the incorrect direction. So you got to be careful with that. Alright. Now, let's continue with the project. It's actually going along really fast. I was expecting it to take much longer than this. Okay, there's that one. And then there's that. Did that actually flow onto the diode? Doesn't look like it. So let's there we go. That's much better. All right. Continuing on. I was kind of hoping more people would show up for this, but I do only have 400 subscribers. Actually, come to think of it, I should probably make a subscribe link. That would be smart, wouldn't it? Apparently I can't do a subscribe link. Alrighty. Well, anyway, if you are watching this at any point, and you haven't already, consider subscribing to my channel. There will be a subscribe link near the stream description. Just click that subscribe link, hit the bell icon if you want notifications of new videos, or if you like to watch me chat inanely as I live stream. Of course, this thing was completely spontaneous. I did not plan this at all, so I didn't have any announcements or watch me build a ionizer on what is today. I don't even know what day of the week is. It's Tuesday, so maybe I'll start. Oops. Oh, hey, I almost started making a mistake there. Okay, come on. The diode there. There we go. Granted, this is far less interesting to watch than a gamer, but I'm not good at video games, really. And I enjoy playing them and all, but I'm not on the kind of league of being able to be nearly as charismatic and funny as people like Markiplier or Jacksepticeye. Which, by the way, those are two YouTubers that actually encouraged me to get into YouTube. Well, they didn't encourage me. It's not like, you know, I was talking to them and they were like, yeah, Chris, you should get into live streaming. It was more of a, or not live streaming, into YouTube. It was more of a, I saw them doing what they love on YouTube and sharing it with the public, and I was like, hey, I have a hobby that I love, and why don't I just start filming it and uploading the results to YouTube? And I started doing that, and then I monetized, and then a couple of months later they were like, yeah, so we're gonna do this thing with, you have to have 1,000 subscribers to monetize. And I was like, oh, darn it. And so I'm waiting to build back up to 1,000 subscribers. I understand why YouTube did that, but it was still kind of upsetting for me, because here I am uploading reasonably original content. The top-down electronics filming is, I mean, other YouTubers do it, but I'm hoping to put my own spin on it. On the subject of other YouTubers that do the top-down, BigClive.com and Julian Eilert were two other people that inspired me to get into YouTube. So, yeah. They're pretty awesome. Big Clive's channel is awesome. I learned more in watching my way through his videos than I ever did in class. Well, no, that's not exactly correct, but yeah, his channel, although I don't know if he actually aims for it to be so, is quite educational to watch and enjoyable. He's it's like a Scottish version of Bob Ross, very soothing voice, and he gets into this really sort of zen, calm sound to his voice when he gets into his work, when he's working on a project. Can kind of hear him get into the groove. I find myself doing the same thing though. I start getting focused in, and so, you know, the whole Bob Ross voice. I really can't explain it any other way. Yeah, so we're nearing the end of the diodes here. It's going much smoother than I'd expected, although I guess I've built 3 of these things so far. Oh, 2 and 7/8. So I guess I've got the pattern down. Alright. Still only 1 viewer. Oh well. I've had a couple of people show up for a few minutes, but they didn't say much. Well, they didn't say anything, and then they went away. But pardon me. Okay, just a few more diodes to go. And then I'll go ahead and kludge together a quick emitter end. And I guess I'll hook it up and... Oops. That was a little too much there, Chris. There we go. I remember I have to clean that off later. Alright. Spin those down. And these down. Position that one a little better. There we go. So, I don't know if anybody has thought of the question, but one of the things that I always wondered when I was looking into these was, if you're adding this voltage up to great high voltages, don't you have to rate the capacitors for those extremely high voltages? And the answer, counterintuitively, is no, you don't. The reason why is because the AC waveform that's going through them is just being shifted up by reference. So if you take your multimeter and you measure across any of these capacitors while it's running, the highest voltage you'll see on any of the capacitors is, in my case, 120 volts, but in the case of Europe, 240. And that's because the previous capacitor just raises the 0 point of the waveform. So the waveform peak to peak is still only 120 volts. But if you reference this capacitor to ground, it will be the added voltage, because the ground reference is being removed entirely from this, and the waveform is just being shifted up in 120 volt steps. Like I said, when I get around to doing a proper video on this, I'll draw better diagrams and make better explanations. I will also link everybody over to a fantastic video done by Dave over at EEV blog, who in 20 minutes taught me more about the Cockroft-Walton multipliers than I knew, than I ever thought there was to know. He's pretty entertaining. He's from Australia. So we got Big Clive and Julian Islet over in Scotland. Well, Big Clive's on the Isle of Man, which is kind of central to Ireland, Scotland, and England. That's kind of weird. Almost looks like this soldering iron tip is going concave. That's kind of strange. Then we've got Dave over in Australia, and maybe one day I'll have as many followers as they do, and the sun will never set on the electronics engineering technician geeks. Although Big Clive is, as I understand it, primarily an electrician, and works with less so electronics and more so electrical sort of things. But he still does a lot of electronics videos and some actually pretty neat content. He's particularly well known for his nearly weekly teardowns of something that involves a capacitive dropper, and by now any fan of his channel can draw a capacitive dropper in their sleep. Every YouTuber has their particular little quirk, little specialty, I guess is a better word for it. There we go. And we're getting to the end here. I feel like I'm still good on the diodes, so we'll just keep going. messy joint. Where's my flux? There we go. Dab on a little bit of flux there. Clean up that joint. I'll probably go through after I've trimmed all of these down more thoroughly and reflow all of the joints with a little bit of flux just to clean them up. Maybe flow on just a little bit of extra solder to round off the ends, help prevent any rogue ionization. So the way the ionizer works is the negative ions will gather at a sharp point on the ionizer. Alright, and then one last diode. How do I want to do this one? I think what I will do is I'll flip this around to that side. Do the same thing here. Fold this up the way, like so. I'll fold this one up the way, like so. And around. There we go. Alright, now we'll just flow these last two joints. There we go. Alright. Now, I'm going to go through here and just quickly clean up these joints a little bit better in preparation for reflowing them with a bit of flux to make them clean. And not pointy, because we don't want any points for ions to start gathering except at the very end of the device. So, just gonna trim these up a little bit. Ow! Stabbed myself. All right. Really running out of stuff to talk about here. Oh, the ionization. So the ions gather at a sharp point, and that is a mosquito that I need to kill. Pardon me a moment. Where did he go? Come here, you little bastard. Got him. Okay. Sorry about that, headphone users. That was right next to the mic, but the mosquitoes here have been absolutely awful. Just exceedingly aggressive mosquitoes. I've never experienced mosquitoes as aggressive as those that are here. It got bad enough one day that we actually burnt a mosquito coil indoors, which technically you're not supposed to do, but it certainly did the trick. We didn't see any mosquitoes in the house for a couple of days. I don't know where they're getting in from. It's not like we leave the door open. I mean, it is summer, so we sometimes leave the windows open, but we have screens. So, I don't know what's going on there. So anyway, the ions gather at a sharp point and stick to air molecules or particles of dirt or any sort of airborne pathogens, and charge them, in this case charge them negatively, to the potential at the end of the multiplier, which should be several kV, ideally. And if you put your hand in front of an ionizer, you'll feel a bit of a cool breeze coming off of it. And that cool breeze is the ions streaming off of that sharp point. Because like charges repel, so they're going to be charged by the ions developing on the point and move away from it. And in a very dark room, you'll be able to see just the faintest purple corona discharge at the tip of the emitter. Now, for the emitter that I'm going to throw together today, and my future emitters, I'll actually be using some carbon fiber. I'll show you that just in a few minutes here when we move from soldering these joints together to the next stage, which is making the emitter. So right now I'm just applying some flux, and then I'm going to go through here and reflow all of these joints with maybe a little extra solder. So it's going to get pretty smoky here for a bit. But I want these to be as smooth as possible. There's no points. Of course, this one is persisting and making a point. Maybe I'll just reflow these and have done with it. I'm forgetting which joints have already reflowed. Okay, so I've quickly reflowed all those joints. Now I've got a bunch more pointy bits that are showing. Oh, that's some very prominent sticky outy bits. There we go. Alright, I know this is probably really boring to watch, but welcome to what it's like to do one of these projects behind the scenes. I'm probably getting way out of shot again. It's a very bad habit of mine. Almost done. Especially at the end here, rogue ionization can be very detrimental to the performance of your ionizer. So I'm going to make sure that I get as many of the sharp points, especially at this end, as I can. Alright, there we go. That seems good enough for now. So the next step is to build an emitter. So I'm going to grab a piece of this. Now what this is carbon fiber heating wire, but it's what I'm going to use for the emitter end of the ionizer here. And then I need to go through my resistors here real quick. Find a couple of big resistors. 2K2, 3K3. No, I want some big ones. 680K, that's more like it. I'm looking for like a megohm. There's 1 meg. Let's see if we can find some 10 meg. 300K. 100K, 470K. 330, 47K. 68K, 220K. 2K. 4.7K. 10 ohms. That's not nearly big enough. 22 ohms, 5.1K, 200 ohms, 100 ohms, 47 ohms, 1K, no idea. Let's see. Red. Why are my lights freaking out? What's going on here? There we go. Alright, I guess we'll just go with the 1 meg. I have a different sheaf of resistors somewhere else that has some higher values in it, but I could not find it when I went looking for it. Alright, so anyway, the emitter, carbon fiber wire. I keep getting distracted. Now we need, there. So when I was saying about how the ionization likes to happen on points, one of the best types of emitter to use is a piece of carbon fiber wire, or a couple of strands of carbon fiber pulled loose from something made of carbon fiber. But in this case, I'll be using carbon fiber heating wire. I'll cut this back fairly generously. There we go. And inside is just a bunch of uncured carbon fiber strands. And you want to kind of fluff them out a little bit. Really, really, really tiny, fine points that the ionizer will rather gleefully produce ions off of. So I'm just going to kind of try to fluff this out into a more of a paintbrushy sort of formation, like that. And then I'm going to take these resistors. Ideally, you're supposed to do this with 10 meg ohm resistors, but 2 meg should be fine. Basically, all it does is make it so that if you accidentally touch the emitter, you don't light yourself up too badly, because the resistor clamps the current down and the voltage. It's one of the weird things about a Cockroft-Walton voltage multiplier is while it may generate exceedingly high voltages, it only does so if it's not under a load. If it's under load, it will drop in voltage very rapidly. So I'm just gonna quickly assemble the emitter end of this. This is mainly just for proof of concept, so I'm gonna flow some solder onto the end of that. I'll turn this down a click. It seems to be running a little high. Weird. There we go. I'm going to do the same thing with this resistor. I'm just going to crop these down a little bit shorter, like so. This is a trick I learned from Big Clive. You tin the end of the solder, or the end of the resistor there, and you tin the end of this one. Carefully, because it will get very hot very quickly. There we go. And then you just flow them together with the solder that you put onto them. Alright, and then I'm going to crop this resistor back just a little bit, like that, and then the resistor and bring it right up into the carbon fiber, just like that. And then I should have, I'll be right back. That was less than ideal. And also painful because I dropped a heavy thing on my foot. Heat shrink. I very distinctly remember purchasing it. Where did I put it? Do. Heat shrink. Perfect. I'm also going to need a source of heat other than the solar iron. That torch should do the trick. Where is it? I remember last using it to ignite the mosquito coil. It's not here. Here. It's not over there. It's not, oh, it's right in front of my face. Alright, now to hold it all together, we're going to put a piece of heat shrink around it. Yeah, this should do it. Actually, I'll see if I can get this tighter diameter one around it. I can actually turn this off. We're done with the solar iron for now. Actually, no we're not. Well. So I actually have to bunch this carbon fiber back up so that I can put this down around it. There we go. Ooh, perfect. It's even a perfect length. Nice, okay. I prefer to use a heat gun for this, but I don't have a heat gun anymore. Okay. So there's that. All nicely heat shrinked in. That's good enough. Do I want to do an extra layer? Yeah, I do. Do an extra layer just a little bit higher. You have to be careful when using a torch because a torch applies way more heat than you actually need. Perfect. Beautiful. All right, now we're going to fluff this carbon fiber back out. There we go. Oops, let's not do that. We've got a couple of rogue fibers that got folded over. There we go. Oh, that should be good enough. Alright, so we actually need the soldering iron back because we have to put this power cable on it. Now, this is the point at which I say, don't try this at home. Also, hello, Phonautical. Actually, what attracts the negative ions in the case of this, being as the ions are so heavily charged, everything that isn't charged to this potential is ground. So it could be the table, it could be the side of the refrigerator, it could be the wall or the floor. And actually, typically around these types of ion generators, you'll develop a sort of a black soot that collects anywhere near the ionizer, which is all of the crud that is being ionized at the emitter and being pulled out of the air. So you don't really need anything to attract to it, because it'll do quite fine on its own. Yeah, so you're getting pieces of dust, bacteria, whatever, that are being charged to several kvolts at the tip of the emitter, and anything nearby is ground to its consideration. Now, my eventual goal with this project is to actually build a ground plane, just a metal plate that's actually referenced to ground, to the earth ground. Oops. Ooh, wow. So smack the camera there. And then that will act as a receiver plate. I've got some big plans for this, but primarily I have to get the thing working first, because these don't work too great on 120 volts, so I need to get that working first. You could run one of these for 5 years, and the tungsten lamp that's above me used more energy in the time it took me to say the sentence. These run for literally pennies to the year. They nanoamps, it is the statistic for them. They use ridiculously little power. All right, so I'm just getting ready to hook my mains cable up to this thing. I need to remember which blade. I think the large blade is the as far as
capacitors, you're going to want to make sure that the capacitors are rated for the RMS voltage of whatever you're running it on. So in the case of these, they are rated for 275 volts AC, which is fine for North America and works fine in Europe as well. In the professional ones, you'll find caps that are rated for 600 and something odd volts, but that's a little overmuch. But as long as it's an X2 cap, you want to make sure that it's a main suppression cap, and it's rated for the RMS voltage of the mains. That should be fine. I think that answered your question. That's a little tight. Yeah, 630s, 1 kV is fine. 100 nanofarads, that's a little on the small side, but it should be fine. Here, I'll show you the schematic again. So this is what the Walton-Cockroft voltage multiplier looks like on paper. You have the mains coming in on this side, and then the array of capacitors and diodes built up like this, with the anodes of the LEDs pointing down the way towards the mains. If you get them pointed away from the mains, you'll be generating positive ions rather than negative ions. Then at the emitter end, you want two 10 meg resistors in series. They don't have to be of any particular voltage or wattage rating, because this thing runs at picowatts, so it's like very, very, very negligible power being generated by this, but it still generates a very good stream of ions. But should you accidentally touch that, you want to make sure that these resistors are in line, because if you touch that, you're going to be a reference to the mains, and you'll get a pretty good tingle off of it. For my values, I'm using 230 nanofarad X2 caps that are rated for 275 volts. Now, I just need to check something, because I can never remember. Neutral. So that's the small blade is the hot wire. That's never made much sense to me, which is probably why I can't ever remember it. Okay, so the small blade is live. That's the smooth wire. I want live to be going to the cap. Perfect. All right. Big Clive, at least on his website, he says that he uses 100 to 220 nanofarad caps when he builds one. Typically, you'll be seeing in the store-bought ones, which you won't find in North America, they have 20 to 60 nanofarad caps in them. Oh, you can't see what I'm doing, I'm way off shot. So right now I'm just tinning the leads of this. Yeah, unfortunately you are the only one here. I've had a couple of people show up for a few minutes, but there's only 411 subscribers, so I wasn't expecting much. But being as I was going to be doing this in the background anyway, I figured, why not live stream it? Yeah, I can't expect much with only 411 subscribers and an unannounced stream, so Not a big deal. So what's your plan? Let's see, what is the smooth cable? Okay, so that goes on here. Why aren't you flowing? Behave. There we go. All right. Well, I mean, I don't think there's enough current flow coming off of one of these to make a light fluoresce, which is what I think you're talking about with the lighting gas under vacuum. For that, you'll need something like a Tesla coil. I actually have one right here. Upcoming video, I make this thing. But the higher the value of the capacitor, the more current flows through the capacitor. So, you know, the larger the cap you use in the multiplier here, the more current is going to end up at the end of the emitter. But the Cockroft Walton multipliers are weird because their voltage step-up thing only works if there's no load at the emitter end. So, I don't know. It's worth some experimentation. I mean, I have a CFL over here, so I can hold it in front of it and see if it lights up. But you don't want to have caps that are too large because it'll turn into an electrostatic generator, and instead of ionizing the air, it's going to charge everything nearby it with static, regardless of it being a positive or negative ion generator. Miss my hot air gun. I was going to say this is mainly for safety, but then I've got a huge line of exposed wiring there, but held for review, tits. I don't know how to make that go through. Well, 1 kV is fine. What's their, how many farads are they? A 100 nanofarad? Okay. Yeah, 100 nano should be fine. 1 kV, just as long as the voltage rating is about 275 or so. But you said they're 1 kV, so yeah, they're fine. Never mind. That's me being dumb. Okay, so now I'm going to... These would be pretty hefty capacitors. Big blobs. I'm assuming they're probably Mylar caps. That's actually kind of interesting. I actually gave some very serious thought to moving to the Isle of Man. I actually have a British citizenship, so I can move anywhere in the UK if I so desire. Really wish I had my Kapton tape. So I'm about to, in a rather extreme example of do not do this at home, I'm about to plug this thing in. I think yeah, there is definitely a flow of air coming off of that emitter, so it's working. I'm not too sure how well it's working, but it's definitely working. So that's kind of cool. Yeah, it's I feel a little bit of movement of air, so I think we've got a good result. Pardon me while I rattle around in the background trying to get my probes. Well, I mean, I'm gonna find somewhere reasonably safe to plug it in and leave it running for a while and see if I start getting some crud developing around it. So, if I take and very carefully probe here and here, that's going all over the place. That's weird. I don't think you can actually probe the voltages here. Yes, as soon as I probe it, it drops down. I was hoping to probe the voltages on the capacitors, but I can't get a reading on it. But yeah, I'm definitely feeling a flow of cool air coming off of it, so it works. So that's a good result. Yeah, it doesn't look like it's sufficient current flow to get a light bulb to light up. These don't really generate a lot of ozone, so it's not something you'll really notice an odor of ozone coming off of. Now I need to ground this out. Is the 1 meg? Oh, those are the 150s. I don't want to have to go through this again and find the 1 megs. I do not want. Great. What did I do with the 1 meg ones? I know I didn't really put them. Ah, there they are. 1 meg. Excellent. What do you need the old TVs for? Oops. Oh, bugger. Where did that go? There it is. Okay. Oh, the big flagellate transformers. You gotta be careful with those. A gigohm resistor. That does seem a little excessive, yes. Although the other day I was browsing Mouser, although actually at this point the other day would be several weeks ago. I was browsing Mouser and I saw something. Tera-ohm resistor. Insane. Humongous resistor. Absolutely ridiculous. Anyway, I'll just do a little quick bonus here. I'm going to kill my lights. So this is a Tesla coil that I've built for a video that's in the pipe. It hasn't been released yet. And there you can see a very, very bright corona discharge there off of the end of that wire. And this produces a very strong ozone smell. Like, I'm already smelling ozone. But, you know, then you can very easily light a compact fluorescent bulb there, see? And actually, that corona discharge isn't showing very well on camera, is it? I don't really want to get my camera too close. See if I can make it show better by putting a piece of black stuff behind it. Of course, I have to wait a couple of seconds for the stream to catch up. There we go. Yeah, there, you can, with the piece of heat shrink there, you can really see the corona discharge on the end of the wire. But yeah, it generates quite a lot of ozone. It's very smelly. And then, of course, you'll notice when I bring the CFL close to it, the corona starts to go away, because the energy that would be coming off at the end of that wire is going into the bulb instead to fire the phosphors. And it keeps that bulb lit for quite a distance away. Like, it's still lit all the way over here. Just a tiny bit. Oh, there, it just went out. You have to get it fairly close again to have it light up. But yeah, interesting little thing. And I can actually play music with this as well, but I don't think I have any DRM-free music on my phone at the moment, so I can't demonstrate it for you. On this one, I honestly forgot to take a picture of the circuit board to reverse engineer it to see what the voltage was, or what the polarity of it was. Typically, Tesla coils and the like try to be negatively polarized, but I don't know. Ooh, those get very toasty. These, there's a transistor and a MOSFET right here, and they get very, very, very warm. But the basic premise of this is that it's using a MOSFET capacitor transistor arrangement to switch the voltage through this loop here on and off very, very, very fast. And that pumps this coil, which generates a nice spark there. And there aren't any great big capacitors in this, which makes it reasonably safe to handle. You won't light yourself up with it. Got it off of eBay for, I think it was $6 Canadian. But the ratio, this is literally a transformer right here, because you've got the primary winding, the single wire here, and the secondary, which is this tube here, which with the fine wire, and it's 350 turns. So this is a 1 to 350 transformer right here. And it's being switched at high frequency by the MOSFET and transistor here. I did the calculation. I'm putting 18 volts into it with that. It can take 15 to 24. I'd like to see what it does at 24, but these get so warm. I'd probably have to figure out a way to mount a fan to it. But at 18 volts in, we're getting 6.4 kV at the tip of this. And it's not current limited, so there's actually quite a bit of current going through this. But it's cool. If you search 12/24 volt DIY Tesla coils, something to that effect, and just find it on eBay. My favorite store on eBay right now is a seller by the name of Alice110198 I think is the username. She, at least I assume she's a she, she's really good customer service, lots of fun, inexpensive electronic doohickeys and thingamabobs. And yeah, a couple of things have been messed up, and she's either refunded me or sent me new ones right away with no complaint or argument. So, really good seller. Anyway, so that's me all done. The ionizer is built, proof of concept, it's working. I may test adding some additional stages to it, see if I can get a bit of bit better performance, but doubling the number of stages from the ones you'd see in the UK seems to work for North American voltage without the need for a step-up transformer. So that's a good result, and I can move on to the next step as I punch my filming rig here. Yeah, I've been streaming for I don't know, about an hour at this point. Hour and a half. Oh, no, I've been streaming for nearly 2 hours. So unfortunately, you kind of came in right at the end there. But I'm going to do this on a fairly regular basis. When I have behind-the-scenes stuff that I'm going to be working on that doesn't really lend itself to making an actual video out of, I'll be doing live streams. This was mainly just a test. This is the first live stream I've ever done, so I wanted to make sure that I had the equipment set up correctly, that it worked, that it uploaded properly and everything. So in addition to the Ioniser being a proof of concept, the stream is also kind of a proof of concept. So yeah, in the future, and they will be spontaneous. It's not going to be a scheduled sort of thing at all. It's going to be oh, well, I have a long, tedious thing that I have to work on, so I may as well upload it and have a conversation with anybody that shows up while I'm working on it. So anyway, thanks for joining me, Fanatical, and we'll see you around in future videos.